This tutorial is part of a series on modules within our central application. This video will cover the use of the oscilloscope application. The oscilloscope has many of the same features that you would expect from an analog oscilloscope that many of us probably still have in our labs. It enables you to look at the signals more closely and with greater time resolution than many of the other central modules. This oscilloscope is a two-channel oscilloscope. Each channel can be enabled separately by using these checkboxes at the top of the window. After enabling a given trace, we can use the drop-down to choose the channel represented from any of our available analog inputs, which include our amplifier channels and B and C inputs on the front of our processor. The color of the trace for that channel can be selected in the exact same way. The Settings button here will simply open the channel properties for that channel. It is important to note that some sort of continuous sampling must be enabled for the oscilloscope to display a trace. Oscilloscope will display whatever the selected continuous data is for that channel, including any applied filters. The control below this allows us to modify the vertical scale of the data. Dragging the bottom slider adjusts the scale in microvolts per grid box. The top sliders can be used to narrow the maximum adjustable range of the bottom slider. As one would expect, the horizontal properties of the grid are applied to both traces. These sliders work in the same way. The bottom slider determines milliseconds per grid box, and the top sliders can limit the range of the bottom slider. Instead of viewing the trace over time, we can choose to instead view a plot of the spectral power density by selecting the frequency radio button. This can be a useful tool for identifying sources of noise, such as large line noise presence, or more unusual frequencies, such as another piece of lab equipment sampling nearby. If we go back to the standard trace by selecting time, we can see another common use of the oscilloscope, the triggering feature. Triggering allows us to focus on a piece of our signal based on a threshold crossing. A very common setup for triggering feature is to use a pulse on the analog inputs as the trigger to observe what happens to a given neural channel shortly after some sort of stimulus presentation. I'm just using sample data, but we can still use it to show the usefulness of the trigger features. I have a repeating square wave on my analog input, 1, that could, for example, represent a sync pulse coming from my stimulator. I'm going to set my milliseconds per grid line to be 100, so it'll be easier to see triggering in action. Additionally, I would like to trigger off channel 2, which I have set to be my repeating analog input. I care about what happens immediately following stimulation, so I'll use only the falling edge of the signal. Nearly done, I will set my trigger delay to -100. The trigger delay determines when we should begin displaying the signal in relation to the trigger condition being met. While it might seem natural to set this to 0, it can be useful to set this to a small negative value to better see the signal just around the trigger condition as well. Finally, I will adjust my threshold for the trigger using this slider until it falls within the amplitude of the pulse that I want to use as this trigger. The triggering function has a few modes. Single mode will fire one time, and then it will not trigger again. Normal mode will fire, and then move into a refractory period where it cannot fire until it has finished drawing the trace. Auto will begin drawing whenever it is triggered. Each of these modes has many different and unique situations where they may be applicable, so the choice is really yours when setting up your own triggering scheme. Sometimes we may want to scroll back in the oscilloscope view to see something that had happened in the past, or to look at a signal more closely. This can be done using the pause and play buttons at the top of the window. If the button is not available, simply select on View and then make sure that Toolbar is selected. After clicking the pause button, you'll notice that a scroll bar appears below our data. This scroll bar allows us to look back in time at previously played data without the oscilloscope continuing to scroll by. Simply click the play button to resume the acquisition of data at the current point. Finally, like many of our other applications, the oscilloscope can have its own configuration file saved to recreate specific setups more easily. To do this, just click on the File and then Save. This saves an oscilloscope configuration file, or .ocf. This can be loaded in the same way that files in other programs are loaded as well, by accessing the same menu and selecting Load. That concludes our tutorial on the Oscilloscope app in Central. For more information on any of our products, manuals can be found at www.blackrockmicro.com.